Hey everyone, Mr. Skelton here. We are back at it, getting ready to start lesson 4 in unit 3. And today we are going to be changing gears, getting away from graphing quadratics in standard form and vertex form, and we are going to be focusing now, moving forward, on solving. And that's going to be important for you to be able to differentiate between solving and just working with quadratics in terms of finding the vertex and answering questions in terms of balls, highest point, things like that. And now we're getting into solving quadratics. So let's get started here. The first thing we're going to be doing is talking about solving quadratics by two things: factoring, call this number 1, and square rooting, which we'll call this number 2. And I'll try to give you some helpful hints as to how to know the difference between when to use factoring and when to use square rooting. And there will be some times where you could use either one, and you got to figure out which one is best for you. So let's just jump right into some problems. I got a lot of problems to get to, a lot of different examples that I want to show you. And so let's start. On each of these slides, you can see the answers down here. So when I tell you to go ahead and start to try one on your own, you can kind of check and see based on the answer that's provided to you if you're on the right track. So number 1 says solving the quadratics. And the first thing we're going to do here is look to factor. Now you'll notice in all of these it is set equal to 0. That is a good thing because we're actually solving for the variable. It's not an expression, and so we're solving here. So when I look at this, if I'm going to solve by factoring, the first thing I want to look for is the GCF, right? When you're solving quadratics by factoring, you're looking for a GCF first. Can you take out something that is in each term? I can take out a 5W. Now when I do that, I have to rewrite when I take out a 5W out of everything, what is left. So if I take a 5W out of 10W squared, that's going to leave me with 2W plus, and if you divide, like I always ask myself this question: what times 5W gives me 10W squared? 2W. What times 5W gives me 5W? 1. Okay? Some students think division, and you can think division if you want. Some students will say, what's 10W squared divided by 5W? 2W. What's 5W divided by 5W? 1. It's kind of how your brain works. Now, we're solving this. So there's something called the zero product property. And you learned this back in Algebra 1. But the zero product property basically says this: if you have A times B set equal to 0, that's the same thing as A equaling 0 and B equaling 0. In other words, if you have two separate terms multiplied together set equal to 0, you can separate them and set them each equal to 0. And that's what you're going to do here. You technically have 5W times 2W plus 1. So what you're going to do is you're going to set each one of those equal to 0, and you're going to solve for W. So here's a situation where we divide by 5, and I get W equals 0, which can be an answer, as you see here. And then I would subtract 1 and get 2W equals -1 and get W equals -1/2. And you can see that answer right there. Okay? On this one here, I would like you to hit pause. You're going to I'll give you a hint. You're solving by factoring. Go ahead and hit pause, try it, and see if you come up with the answers provided here at the bottom. Okay, so when I look at this, the first thing I notice is that this is a trinomial. And in my math experience, I know that I can factor trinomials by timesing two binomials together. I look for a GCF. I do not see a GCF, a greatest common factor that can come out of each one. My mind immediately goes to this. What two numbers multiply together give you -18. Add together, you get -3. Well, list all the factors of 18 if you need that. But that should be a -6, right? And a +3. -6 times 3 is -18. -6 plus 3 is -3. Now, I use the zero product property, and I set x minus 6 equal to 0 and x plus 3 equal to 0, and I solve, and I get x equals 6, and I get x equals -3, and those are my answers. Moving on. More solving quadratics here. So now, if you look at that trinomial, technically these should be equal to 0. That one should be, that one's correct. Again, first rule of factoring, GCF. Does it have a GCF? It does not. Okay, what do I have? I have a trinomial, 1, 2, 3 terms, and I'm probably going to have to go down our friend the box method We've seen this a time or two, right? Probably rolling your eyes or making some moaning sound of discontent here. 2x squared and 6, my new c value is going to be 12. So what 2 times 6 is 12. What two numbers multiply together give you 12? Add together, you get negative 7. Negative 4 and negative 3. Put your x's in there. Going across, 2x. Going across, since that box is negative, negative 3. Going up is x, and going up is negative 2. So I get 2x minus 3, and then I get x minus 2, and those are set equal to 0. So, zero product property, 2x minus 3 equals 0, and x minus 2 equals 0. So I get x equals 2, and x equals, I'd add 3 and divide by 2, which is 3 halves and 2. Okay? Let's take a look at number 4. Can you pull out a GCF out of all 3 of those? You cannot. Some people, sometimes when they see 3 and 16, they think that they can do that. So again, I'm going to use box method here. So 3x squared, I'm going to kind of move fast just for the sake of time. 3 times negative 12 is a negative 36. So I need 2 numbers that multiply together give you negative 36. Add together, you get 16. Well, you may need to break your calculator out and start figuring out what numbers are going to make the 16. It ends up being a negative 18 and a positive 2. Check it. Negative 18 times 2 is negative 36. Yes. Negative 18 plus 2 is negative 16. Good. So greatest common factor going across, 3x. Going across, positive 2, because that box is positive. And then x. And then going up, I'm going to have 6. Right? 6 is the largest number, negative 6, because that box is negative. Negative 6. So I get 3x plus 2. And x minus 6, set equal to 0. 0 product property, so 3x plus 2 equals 0. X minus 6 equals 0, so x equals 6. And x equals negative 2/3 when I subtract 2 and divide by 3. And you can see that right there. Okay? All right, down towards the bottom now, we're going to get into a couple different problems here. This one looks crazy. If you recognize that 25 and 81 are perfect squares, which they are, this will factor into 5x plus 9 and 5x plus 9. Okay? And you can go through and FOIL this out. Now you could do box method here, but it would be a massive headache for you if you're just thinking ahead. But sometimes these factor out, and you should go back and multiply 5x times 5x, 25x squared. That's going to give me 45x. That'll give me 45x. 45x and 45x make 90x, and 9 times 9 is 81. So it does factor out. Now, you're probably wondering, well, do I have to set these both equal to 0? No, you're just going to have one answer here because these are both the same. You don't have to write it twice. So it's 5x plus 9 equals 0. You would subtract 9, so get 5x equals negative 9, so x would equal negative 9/5 when you divide both sides by 5. Okay? Now, if you remember at the very beginning of the lesson, and I'll go there real quick for you, we said we were going to solve quadratics by 2 ways, 2 methods, factoring, and that's what we've done so far, and then square rooting. And I said on some problems you can do either one. So like on this example here, I'm going to show you both ways. So I recognize this, and I know that this is a difference of squares, which factors into 3x plus 8 and 3x minus 8, right? And if I set that equal to 0, I'd get 3x plus 8 equals 0 and 3x minus 8 equals 0. I'd subtract 8 and get x equals negative 8/3. And over here I'd add 8 and get x equals 8/3 because I divide by 3, which is what I have here. The other way you can do this problem, and this is what I would do if students have a hard time, here's kind of a little trick. If you just have an x squared, right? I said at the very beginning that you can solve by factoring and square rooting. The only time you can solve by square rooting is if you just have x squared in the problem, all right? And what I mean by that is this. If you look at you look at these questions here that we did. You have an x squared, but you also have an x. You have an x squared, you also have an x. This one we just did. X squared, but you have an x. Look at this problem. There's just an x squared. So the other way to do this problem, if I have some room here, is I'm going to just solve this by adding 64 to the other side, right? And then dividing by 9. So I can take 64 and divide it by 9. Now, if you get a really cruddy decimal, so let me show you this. Don't make it a decimal. Just get x squared equals 64 over 9. Now, how do you solve for something x squared? You square root. And any time you introduce the square root, it's got to be plus or minus. What's the square root of 64? 8. Square root of 9? 3. And what do you know? You get the same exact answer. Okay? All right, so let's flip it over. We're mowing through these here pretty quickly. I want you to go ahead and hit pause and try 7 and 8 on your own. And when you're done, check with me. Okay, so sometimes you'll come across some equations where not everything is put in standard form. We want to make sure that we have things in standard form, especially if we're going to be factoring. So you'll notice here it's equal to 6. So I want to subtract that 6 over to make sure I'm in standard form. Most of the problems we did prior to this were already in standard form, but just make sure that it is. Now, I can take a GCF. I notice that I can take a 2 out of all of these. Leaves me with x squared plus 2x minus 3 equals 0. And then I can factor this into an x. What two numbers multiply together give you negative 3. Add together, you get positive 2. That should be a positive 3 and a negative 1, right? 3 times negative 1 is negative 3. 3 minus 1 is 2. And this 2 stays out here. Now, technically, when we do the zero product property, I have this 2 equal to 0. I have x minus 1 equal to 0. And I have x plus 3 equal to 0. The most common mistake I see on a problem like this is students will tell me that x equals 0 is an answer. If you notice this right here, where it just notice I have no variable. So this 2 equals 0 is absolutely nothing. Technically, it needs to be set equal to 0, but since it's 2 equals 0, that really does nothing for us. So we really want to focus on anything that has a variable. So I get x equals 1. When I add 1 to the other side, I subtract 3 to both sides, and I get x equals negative 3. That's my answer there. On number 8, I noticed just an x squared. So for me, I'm going to go down this path, which is 3x squared. I'm going to add 24 to the other side. I'm going to divide by 3, and I get x squared equals 24 divided by 3 is 8. If you can reduce. Like on the one previous, I couldn't. I got a decimal, but I get a nice neat 8 here. I square root. So I get x equals plus or minus radical 8. Anytime you can simplify radicals, you're going to have to do that. So I break down 8 into 4 and 2, which gives me 2 radical 2. So plus or minus 2 radical 2 is my answer. Next, we've got a word problem here. Let's read it and see what we have. It says a parachutist free falls until he hits 1,000 feet when the parachute opens. The height of the parachute is given by this equation. How many seconds did the parachutist get to free fall? So what do we want to find? We want to find time. Okay? So what we want to do here is figure out, let's see, the height of the parachute is given by this equation. The parachute free falls until he hits 1,000 feet. So how many seconds does the parachute get to free fall? When it does is this. So we put in 1,000 feet at h because we want to know how long he was able to free fall when he got to 1,000 feet. T stands for time here. H obviously is going to be height. Always important to write down the variables. And you can see here we've plugged in the 1,000 for h. Now, we want to set this equal to 0. So I get negative 16t squared. Let's see, plus, what? No, never mind. Take that back. I'm going to subtract, because I just have t squared, I'm going to subtract the 1,600, and I get negative 16t squared equals, that's going to be negative 600, right? And then I'm going to divide by negative 16. So I'm going to get 600 divided by 16, which is going to give me t squared equaling 37.5. And then I'm going to square root both sides. So I'm going to square root that answer. And I'm going to get t equals 6.12 seconds. So, sorry I got a little sloppy there, but I didn't realize I had the equation written in here for you. Most of the time, though, I'll give you just something like this. And you're going to have to know to plug in the 1,000 feet for h. I guess I kind of forgot that I put it in here for you. But again, you're solving for time when the parachute is at 1,000 feet. So we know it's 6.2 seconds. Okay? So a lot going on here with solving quadratics. You did this in Algebra 1 as well. You may not remember it, but hopefully a lot of this is review for you. And if you have any questions, as always, I'll see you in class.